Hello, this is my Physics 2211 Lab 1. The purpose of this lab is to practice analyzing a system with constant velocity and applying Newton's second law. For this lab, the system was an orange that I rolled across the surroundings, which was the ground. The goal was hopefully to have a low coefficient of friction and therefore a low friction force, to see a low loss of speed due to friction, to get as close to a constant velocity as possible. In this report, I will analyze the actual data collected using a tracking software and compare this data with two computer models. One computer model does not account for force applied, and the other does account for a force applied, in this case, friction. In the end, it will be obvious that our system did lose some energy due to friction. After recording the orange rolling, I used a tracking software to collect the data of where the orange was at each frame. After calibrating the software, we had accurate data of where the orange was over time. I then copied this data into Excel and made my graphs. I used trend lines from these graphs to calculate a few figures which I would incorporate into the models I'm going to make next. I then made two models. I used the initial values from the recorded data, which include the initial velocity and initial position, and calculations from the trend lines, which included the average velocity and average acceleration. The first model is the zero net force model, which has no force applied and therefore no acceleration. You can see this in the code where when updating velocity, we set it equal to itself, so there is no increase or decrease in velocity, therefore held constant. In the graphs, we can see that the ball's position is changing at a constant rate and that the velocity is held constant. The second model I made is a little bit extra. I used acceleration to account for the force of friction that the ball experienced. This model should be closer to the actual data because it accounts for a force that was actually there, and we can see this in the code. When updating velocity, we use the acceleration vector to make the velocity vector more positive and slow down speed because we are already traveling in a negative direction. In the graphs, we can see the change in velocity in the velocity over time graph as it is slowly becoming a more positive velocity, and in the position over time graph, the change is not exactly linear, it bends a little bit. After copying the data from the models into Excel, I was able to compare the models against the actual data. When looking at the comparison with the constant velocity model, which has a net force of 0, it is clear that the system did experience friction and as a result slowed down. When looking at the comparison which accounted for friction with a constant acceleration caused by the force applied, it is clear that it is more accurate representation of what really occurred. Now for the what if. If I flip the axis when I first tracked the orange, then the orange would have moved in the positive direction. All of the vectors would flip directions, but the scalar values, like the mass of the orange, would remain the same. What does this mean? In a perfect world, the zero net force model would be perfectly accurate. This would require that there is no friction force and that the force, normal, and gravity are perfectly equal and opposite each other. This, however, is not the case because we recorded this orange in the real world, where we were not able to eliminate completely the force of friction on the orange. It is not possible for us to say the total amount of pushes and pulls that added together to get us our net force. In this case, because we do not know the exact number of forces that went into this, we do know it included the normal force and the gravitational force. However, we do not know if the normal force was also split up between the x and y component, which would mean that the surface we were on was not perfectly level. We also did not account for air resistance, which is just friction due to the air. So it is not entirely possible for us to say how many pushes and pulls we had.